Welcome to our video on Spring Security with JPA Authentication. In this video, we will show you how to secure your application effortlessly using Spring Security in combination with JPA. First, we will demonstrate how to configure Spring Security with JPA Authentication. You will learn how to define your security settings in a configuration file. Next, we will show you how to create custom user entities and repositories using JPA. These entities will represent your application's user and their authentication details. You will understand how to map user roles and permission, granting or denying access to specific resources within your application. Then, we will guide you through the process of implementing password encoding and authentication. We will use password hashing technique to store your password securely, protecting sensitive information from potential breaches. By the end of this video, you will be well equipped to implement Spring Security with JPA authentication in your own applications. You will have the tool and knowledge to protect your application and ensure that only authorized users can access its resource. Hope you will enjoy it. Let's write some code. I'll start the project from scratch. For creating a new Spring Boot project, I will use my favorite online Spring initialization tool. Go to start.spring.io. Make sure you have selected Maven project. Choose latest version of Spring. At the time of my recording, the latest version is 3.1.5. You need to choose jar packaging and make sure to choose Java version 17. In the project metadata, give it a group name, give an artifact name, Spring JPA Auth. Name is automatically generated from my artifact name. I do not need to change this. Let's provide a description. Spring Security JPA Authentication Project. It's time to add dependencies. First, I need to add Spring Web. I want to expose some endpoints. Then I need Spring Security. Need to add Spring Data JPA for Java Persistence API. I will use MySQL for my database. So additionally, I need MySQL driver. Now click Generate. It will download the project in zip format. I have unzipped and imported the project into my IDE. I am using the Intelij IDE Ultimate version. You can use whatever IDE you are comfortable with. Now start the project. It fails to start. Let's check the reason. Open the console. Failed to configure a data source. The URL attribute is not specified and no embedded data source could be configured. The primary reason behind the error is that JPA requires a properly configured data source to connect to database. If Spring cannot find or configure a data source, it will throw this error. So, let's configure our project for database connection. I am using MySQL database for this project. Let's connect with my database. Intelij IDE has a built-in tool to communicate with the database. This tool is available in this Ultimate version. If you do not have Ultimate version, you can use a free tool like MySQL Workbench. Okay, let's start with that. Click on this database icon on the right panel of the IDE. Or you can open it from View, Tool Windows, then Database. Click on this plus icon to add new database connection. Data source, I need MySQL, so filter for it. Click on that. If you are using first time, you may need to install a database driver for MySQL. Let's download it by clicking here, the download button. It has downloaded the driver. Give it a name. I will keep with the default one. Give the host. In my case, it's localhost. and the default port for MySQL is 3306. Give username, then password. Now test the connection. Make sure you get the message succeeded. Otherwise, review your configuration. Now everything is okay for me. Go ahead and click OK. And the first thing I will do is create database schema. Right click on this database source, new schema, give our schema name Spring _ JPA. Now let's establish a connection between our application and the database that we have created. Open application.properties from src main resources. Rename it to application.yml. Using YML file for setting up the properties is just my personal preference. You can use your old application.properties file, nothing wrong with that. It's time to provide our database information in this file. So add Spring data source URL. Here we need to provide our database connection URL. For MySQL, it is jdbc:/mysql:// then localhost. This is because I have my database installed in my local server. In your case, you may need to provide your IP address of your server. Then provide the database server port. In my case, it is 3306. Then / name of the database schema. Next, we need to provide our database username. My username is root. Now provide our database password. It's time to give the driver class name. For MySQL, this is com.mysql.cj.jdbc.driver. This driver class is used to establish a connection to database from our Spring Boot application. Now, we need to provide a couple of other properties like JPA, show SQL. I want to see my query on my console, so make it true. This is only for my development purpose. Usually, when I deploy the application to that production server, I mark show SQL as false. Our database is MySQL. Next, we need to provide a database platform. We can give it as database-platform. And the value of our platform is org.hibernate.dialect.mysql8 dialect. You may have question about why we need this dialect. Hibernate dialect specifies the type of database being used, allowing Hibernate to generate appropriate SQL statement for that specific database. In this case, Hibernate will generate SQL query for my MySQL database. If we have an Oracle database which has a slightly different query structure, we will have to add Hibernate dialect for that Oracle database. That will generate SQL query for the Oracle database. Okay? And then on the next line, Hibernate, inside Hibernate, DTL, O2. The standard Hibernate properties values are none, validate, update, create, and create job. What it does is that we can tell Spring Boot what to do with database table when starting our application. When we give create job, then Spring Boot will create the database table when it starts and delete it when stops. If we give it a create, then it will try to create tables when the starts but will not delete when we stop our service. On the other hand, in case of update, Hibernate checks the database for details and compares it with the information from our code. It tries to make adjustment to the database structure, like adding new columns or table, but won't remove anything that used to be there before. I am going to use this update here. Next, I would like to see query formatted for better readability. So we need to add properties, inside properties, Hibernate, then format SQL and set it true. That's all for now. Take a look at this indentation. You have to be careful with this. Indentation of this JPA should be the same as the indentation of data source. Take a careful look at overall properties. If you feel confused, please check the source code from my GitHub or give me a comment below. Let's start the server and check what happens. Now the server has been started at port 8080. It also generated a password for login into our system. Let's check it in the browser. Here is our login page. The default username is user and the password is the random password that is generated by Spring. But we don't want to use those. We want our user information to be stored in the database and we will use that information to log in the user to the system. Let's start doing that. First, let me give you a summary of what we need. We will need a security configuration class for configuring our Spring security to use JPA. Next, we will need entity class. I will call them models. One is user and another is roles. These classes will represent the table in our database. For example, we will have user table with couple of columns that will be represented as a user entity. Similarly, the role table will be represented as role entity. Feeling confused? Don't worry. We will explore it here. Hopefully, it will make your concept clear. Next, we will need repository classes. The repository class is responsible for the communication with the database. We will also add a service layer so that we can separate the database logic from our controller. The controller will be responsible for handling and processing URLs, and they will talk to the service classes, and then the service classes will talk to the repository and entity classes to handle database queries. Now let's start by creating package for our models. Right click on the project, new package, give it a name, model. Inside the model package, add a new class. Right click, new, Java class. Make sure this class is selected. It will be our user class. Annotate it with @entity to make it entity class. Give annotation @table. Inside the parentheses, give the database table name that you want it to be mapped. I will give it user. This name does not need to be the same as this class name. This can be any name, like you can give it a name like admin_users. In that case, it will be mapped to admin_users table in your database. I'll go for the user. Next, we need to provide our entity class a primary key. To do so, give an annotation ID. I want to map it to the ID column of my database table, so give another annotation @column. Provide our column name. In my case, it is ID. Next, declare a field. Our field type is integer and name is ID. Let's import the class for ID annotation. Here are two packages available from where we can import the annotation. Make sure you have selected Jakarta persistence. We need to add another annotation to this primary key to let Hibernate know how to generate the ID. This is using addGeneratedValue. Inside parentheses, give it our strategy, generation type .identity. This strategy relies on the auto increment functionality, provide the database to generate unique identifier values automatically. Next, we will need a username. So, column, the name of the column is username. Field type is string and the field name is also username. Now we need the password column. Column name password. The field type is string. Field name is password. It's time to give our user a role. Our users can have multiple roles. For instance, an admin handles the behind the scene task that keeps the company running smoothly. They are also considered as a staff member of the organization. So, our user will have list of roles. Let's create our roles class. Mark it as entity. Map it with the role table. Give it the primary key ID. The column name is ID. The field type is integer and the name is ID. Add generated value. Strategy is generation type dot identity. Next, give our role a name, column name, field type string, and the field name is name. Now back to the user class. Annotate the role with one-to-many annotation. We are using one-to-many relation because our users can have multiple roles. We want the role data to be loaded from the database immediately when the user entity is loaded. So use fetch equal fetch type eager. Now we need to create setter and getter for both of the class. First, in the users class, inside this class, right click, generate, getter and setter, select all and click OK. Do the same for role class, right click, generate, getter and setter, select all and click OK. Now start the server. Look at the console. Here is our Hibernate query. Hibernate has created a table in our database. This is the query for the role table and this one is for user. And finally the mapping table for our user and role. Let's connect the database from my database tool. Here is my database. This is my schema. Let's expand it. Need to refresh. Just click here this refresh button to refresh the database. Now click this arrow to expand this. Here is showing that I have 3 tables. Let's check it. Expanding. See, we have 3 tables: role, user and user role list. For role, we have 2 columns. One is ID and another is name. And on the other hand, for user, we have 3 columns: ID, password and username. Similarly, this is our mapping table, user role list. It has 2 columns, user ID for storing ID of the user and role list ID for storing the ID of the role. Okay. Back to the IDE. Create a new package repository for holding repository classes. A Spring Data repository is an interface-based definition used for accessing and managing data. It provides methods for common data operations such as reading, writing, updating, and deleting records. These methods are defined in the repository interface, and Spring Data automatically generates the necessary implementation based on the method named and query derivation strategies. Now, let's create a repository for our user. Right click, new, Java class. Make sure this time select this interface. Name it UserRepository. This repository extends the JPA repository from Spring Data. Then give an angle bracket. Inside the angle bracket, give our domain type that it will manage. In this case, it is users. And next, give the data type for our primary key. Our primary key is ID, which is an integer. This integer is a primitive data type. JPA repository does not accept it. Rather, it requires a wrapper class of integer. Let's provide it. Also, update the data type of ID of our user class. Update the setter and getter method for the ID. Do the same for the role class. Now, let's configure our Spring security to use our user from the database. Create a new package, name it config. Inside config, create a new class, SecurityConfig. Annotate it with @configuration to mark it as a configuration class. Inside class, we need to create a bin of security filter chain and name it security filter chain. It accepts the HTTP security object. Name it HTTP. Inside the method, provide HTTP dot form login. We will use the default login form for now. Then we need to provide UserDetailsService. Here we need to pass our custom service which will implement the Spring Boot's UserDetail service. Let's create our service. Create a package, service. Inside, create a class, UserService. Mark it with service annotation. This class will implement UserDetailService from Spring Boot. This requires a method to be implemented. Let's implement it. loadUserByUsername. This accepts a username as a parameter. In the return statement, we will give our user fetched from the database. We will query our database to get the user by their username. Open our UserRepository class. Here, create a public method of return type user. Name it findByUsername. This findBy is the convention of Spring Data JPA. After findBy, we need to provide the field name by which condition we want to query our database. In our case, we want to query by username. We do not have to do anything else. Spring Data JPA is smart enough to create a query on its own to fetch the data from our user table. So, in our user service, this method needs to return a type of user details. So, open our user model, implements user details from security core user details. This needs some method to be implemented. Let's implement it. Select all the method and click OK. Here are our methods. First, getAuthorities. This method is for getting the list of roles, or you can say the authority that the user have. We will get all the roles that the user has and push it into the list of array of type granted authority. Create an array list of type granted authority. Now loop through the array list of our roles. I will use for each loop to do that. For the data type is role and the list is role list. Inside for loop, here create a new simple granted authority object. Simple granted authority actually the implementation of the granted authority interface. Here pass the role name as a parameter, role dot get name. Add this thing to our authority list and finally return our authority list. Here are our remaining methods. This one is account non-expired. Make it true. Another is account non-locked. This is also true because we are not implementing any lock or unlock functionality of the user right now. And is credential non-expired is also true. And finally is enabled. Make it true as our user will be enabled by default, and in this video tutorial I have no intention of disabling the user. Now to our user service. Add a private field of type UserRepository. Name it repository. Mark it as final. Inject it using the constructor. Right click inside this class file. Generate constructor. Select this user repository and click OK. In our loadUserByUsername method, return repository.findByUsername. Pass username here. Now go to our security config class. Add a private field of type UserService. Name it UserService. Mark it as final. Inject it with the constructor. Generate constructor. Select UserService. Click OK. Now here, give our user service as the parameter of UserDetailService. Finally, call build method. This throws an exception. Let's include it to the method signature and return the whole thing. Run the server. In the browser, go to localhost 8080. It's now showing 404 error. It's trying to access the root URL, but I want it to be protected by default and user needs to log in to access this. So in our security config, after from login method, add authorize HTTP request. inside parentheses, lambda expression, req, arrow, req dot any request. I want all incoming requests must be authenticated. Let's move it to a new line for better readability. But there is an exception. We want all users can access the login URL. So, before applying this restriction, add dot request matchers, give our login URL, followed by double star and permit all. Now restart the project. Check in the browser. Here is our login form. Currently, our database is empty. We do not have any user and role saved there. So, let's add a new user to the database. Now, open the database tool. This is the database. This is our schema, then table, then user. I need to add a new user in this user table. Right click this user, then edit data. Let me minimize this tool window. It's showing data from our user table. Currently, we have no data here. To add new user, click on this plus icon. This auto increment ID will be generated by MySQL, so I do not need to provide any data here. Let's give it a username of admin and give password. Saving this type of raw password straight into the database is dangerous. We need to hash it so that if the database is compromised, the hacker will not be able to get actual password. We will use bcrypt password hashing technique. Let's use an online tool to generate bcrypt hashed value of our password. Go to bcrypt-generator.com. Here in the string field, provide our password. Click on encrypt. Our hashed password is generated. Copy this and paste it in our password column of user table in the database. Now, click in this arrow here to commit our changes in database. A new user has been saved to our database and the generated ID for it is 1. Now, it's time to add role. Select role table, right click, edit data. Let's minimize it. Here, click on this plus icon. As I mentioned before, we will have two roles. One is admin and another is staff. So, go for the first one. It is admin. And the second one, click on the plus icon. Name is staff. Commit the changes to persist. Our role has been saved. Role for admin is 1 and staff role is 2. Now let's assign admin role to our user. So again from database tool, open user role list table, right click, edit data. Here click on this plus icon. In the user ID column, provide the ID of our user. The user ID is 1. For admin role, the role ID is also 1. So role list ID is 1. Now commit the changes. We have assigned a role to our user. Let's close those. Now run the project. The project is started. Open the browser. Provide username, password, sign in, login failed. Let's check it from the console. This is our query. This is our error. There is no password encoder mapped. Okay. That is because we need to specify a bin of password encoder to let Spring know which password encoding technique it needs to follow. So in our security config, add a new bin, password encoder. Name it password encoder. Return new bcrypt password encoder. That's it. Run the server again. Check the browser. Refresh. Provide our username, password, sign in. Okay, it's successfully signed in. But it's showing this 404 error page because we have not configured any endpoint for this root URL. So let's do it. Create a new package, controller, inside new Java class, name it dashboard controller, annotate it with REST controller. Now provide get mapping for root URL. Give a public method. Return type is string. Name it dashboard and return a simple string. Welcome to dashboard. That's it. Run this project. Open the browser, refresh, provide username, password, sign in. We have successfully logged in. That's why we are able to see this text. Now come to the authorization part. Let's assume we have two endpoints. One is admin and another is staff. Admin endpoint is accessible only by admin user, while staff does not have any access to that endpoint. And staff, where admin and staff both can access that. So let's create two endpoints in our controller. Minimize the console, stopping the server, close this project menu for making some room. First one, get mapping for admin. Public method, return type is string and method name is admin. Return a simple text. You can view this only if you are admin. Now add another endpoint, staff. Public method with return type of string. Name it staff. Return a simple text. Now in the security config, after this whitelisted URL, add dot request matchers admin followed by double star has any authority admin. Only the admin will be access this page. Again, dot request matchers staff followed by double star has any authority admin and staff. So what we are doing here is that this admin page will be accessible only to the user who has admin role. But for staff, if the user has role either admin or staff, he will be able to access it. And the root URL will be accessible by all. Now in our database, let's add new user for our staff. From database tool, user, right click, edit data, click on the plus icon, add username for staff. For password, copy the previous one and paste it. Done. Commit the data. Staff user has added and the ID is 2. So in our role user list, edit data, here is user ID column. Our newly added user's ID is 2 and for the staff role the ID is 2. Commit the data. Now let's start the project and see what happens. Open the browser, refresh, give our admin user password. We have logged in. It is our root URL. Let's try to access admin page. It's accessible. Now access staff. This page is also accessible to the admin. Now log out. Try to log in using staff user. Password. Login. Again the root URL is accessible by all the authenticated user. Try to access staff page. It's available for staff. Now let's try to access the admin page. This is 403 error. That means staff does not have any permission to access this page. And that brings us to the end of this video tutorial. I will be returning with another one very soon. In the meantime, keep learning, keep exploring, and most importantly, never stop. Happy coding!